So you have ionic versus covalent. So the first thing I do when I look at a compound is I figure out, is it ionic or is it covalent? If it is ionic, I'm gonna think about sodium chloride, in which I know the first thing I do is write the name of the metal. So it'll be literally exactly as it is. It will be sodium. Right, so it'll be the name of the metal. Same thing for this other one, it'll be just iron. You just always, if it's ionic, the metal is always the first one, the most positive is always the first one, no matter what. And then if it is one that we already know the charge, like what is the charge of all of sodium? You know it, you got to know it. Charge of sodium, lithium, potassium, rubidium, cesium, francium, +1. We know it, so I don't have to write it because everybody in the whole universe knows that all alkali metals are +1, right? So you don't have to write it. If you write it, it's wrong. The alkali earth metals, do you know the charge? Ooh, we're missing a kid next to you. +2, right? So so we don't write those either. Now the boron group is usually what? William?
You said the
Boron group. So we have alkali metals, alkali earth, then we have the boron group.
the transition metals?
No, boron.
Boron.
Yes.
That's
What will be the charge?
+4. +3.
+3. So +1, +2, +3. So you don't write them for those, right? You know, +1, +2, +3. That's where that falls. So we call sodium, and then we put the name of the non-metal. But like in all compounds, everything is gonna finish with an I. All of them are gonna finish with an I. So the non-metal will always end up an I. Now, if you have a transition metal, like iron, Aiden, then do you know the charge of iron? Where is iron? Yeah, so do you know the charge? So the compound will tell you, but the name has to tell you what it is. So you're gonna have to write Roman numerals. So you need to know your 1, your 2, your 3, 4, 5, all of those, you've got to know those. Everybody knows them? Okay, good. So it will be iron, and he's right, it's iron 3. Oxide. Like I said, everything ends up in I. So if I know I'm dealing with a transition metal, I have to use the Roman numeral because you have to tell the person. Like there's no way I could write that if I didn't have that 3. I don't know if it's iron 2 or iron 3. I wouldn't know. If I had to write that compound, I will know that it has an iron, right? I will know it has an oxygen, right? Everybody, because of iron 3 oxide, I will know that. But without the 3, and I know oxygen is always what? Caroline, what is the charge of oxygen? -2. She didn't even look at the periodic table. That's good. -2, I will know that, but without me putting that 3 in here, there is no way I know. It could be iron 2, it could be iron 3, it could be another charge. So that will tell me that this is going to be a +3. And what we normally do, not all the time, but 99% of the time, we just take those charges and put them opposites, which is what Aiden was talking about, and we get it right. What are we looking for? We are looking for a compound that is neutral. -1 and +1, that's neutral, right? Salt is neutral, it's not charged. Salt is neutral. When you dissolve it, then you get ions with charges, you get electrolytes, but it's neutral. So here, normally, if we do that, if we crisscross, we have 3 oxygens. Each one of those is a -2. So we have a total of -6 charges, right? We have 2 irons, each one of those with a +3 charge. That's plus 6. Plus 6 minus 6 is equal to a 0 charge, which will lead me to a neutral compound, which is what we have to have, because that's not an ion, that doesn't have a charge, right? So that's what we're looking for. Are we okay with that? I do put videos and stuff on things like this, not done by me, because, I mean, this has been done, it's like making peanut butter and jelly sandwich. It's been done forever, the same way. So we don't need to make a video explaining it better than anybody else. It's just the way it is. Most people do not memorize compounds like I do. They just memorize the rules. I can't memorize any rules. So I know if it looks like that and it has those, it's 1, 2, or 3. I don't know why I deleted it. Or on the third group, then I use the name and that. If it is a transition metal, then I know I'm going to have to tell the person what charge it is playing with. There are some exceptions to this that I just told you. The exceptions are, and the first one is not really an exception because aluminum should have what charge, Alex? Yeah. All of you are shows, don't even look. But yeah, aluminum is plus 3. So that one, but if you look diagonal, the one diagonal to it is zinc. Zinc is plus 2. And the one diagonal to that is silver. And silver is plus 1. And those, the universe knows, are plus 3, plus 2, and plus 1. Right? Everybody knows aluminum, but you need to look at the diagonal. They should have a little yellow highlight on the number. That's how I kind of show people that they have plus 3, plus 2, plus 1. So if you have aluminum, it's always going to be plus 3. We knew that. Zinc is always going to be plus 2. And silver is always going to be plus 1. They could have other charges, by 99.9% of the time is this. So if you have those charges, you do not write it. You do not say anything. Everybody knows that that's what they are. So you need to know those, and they are diagonal. If we have the periodic table, I can't see it, but I know I have yellow circles around the atomic numbers of those. So if you know what I'm talking about. Now there are two others that are not necessarily what we call transition metals, but they are in the metal section that are actually under carbon. Tin and lead. They normally are at 2 or 4, normally. So you're gonna have to write the Roman numeral for those, right? Tin and lead, you normally have to write this Roman numeral for those two. They don't follow in what we normally call transition, but they somewhat are. They're just metals. But tin and lead, you're gonna have to write it. That's all the rules for ionic. That's it. Oh, we have ionic compounds that have polyatomic ions, like Ag, NO3. You do not know the name of this polyatomic ion yet. I will have to give it to you, but you're going to learn it within the next few classes. So AgNO3, how would you call that? I keep forgetting your name. I know it starts with an A. What is it? Akashi? Akashi. So how would you, if you had to guess, because it's the first time, I don't even know if you have it on your master in chemistry, but if you had to guess, based on these rules, how would you call this compound? Ag is silver. So you will write the silver. Would you write the Roman numeral or not? Silver. Do you think? Yes? So what is the oxidation number? How did you know? Because it's always 1, right? So you don't write it. Aluminum, zinc, and silver follow under this category, right? So you don't write it. You think you should because it's in the transition metals, right? You should write it. But those are exceptions. you do not write it if it's one that the whole universe knows about, right? So aluminum, zinc, and silver, you don't write them. And it's good that we have this so that you realize, do not write those. And the other thing that is true is I don't call it nitride, although that's a nitrate. Anytime you have a polyatomic ion, you just let it be. So this will be silver nitrate, which is what we're going to use on our lab. It's going to be silver nitrate. So this is even easier, right? You don't have to remember the I, which goes with all the ionic compounds and all the covalent compounds as well. I goes for all the nonmetals, period. But these ones, you do not have to have a Roman numeral unless it's a transition metal, and then you have to put the Roman numeral. Is that right? Is that okay? Now, covalent. What compound did I want everybody to always think when you're thinking covalent? If we were thinking properties, what compound did we talk about? There are two compounds we talked about. Sugar is one of them. So that is C. Sugar. And then we have another one that will help you more with the characteristics. That we breathe in, breathe out, do something with it. Which one is it? Carbon dioxide. And that's the one that will tell me how to name carbon dioxide. The one on top is just going to tell me there are a lot of organic compounds that are covalent. They just have their own names. And Ms. Purnell is going to have to go over organic compounds, likely, in biology. I'm not. We'll know some, but they have their own names, right? We call water, water. It's not organic, but we call water, water. We call methane is CH4. You just have to memorize some of these ones. And there are some that have rules. If the class goes fast enough, we will get into this. But there's some that we're not going to care. Now, when they're binary, what do you think binary means? No. It's not Sophia. No, you're not Sophia. She's showing me. Rihanna. Now I forgot. But if you have to name, what does binary mean? Two different elements, right? Bipedal is two pedals, binomial, bi is always two. So if you have two different elements, then you're going to do this. You're going to use something called Greek prefixes. And again, some of you are a little bad at this, I know, because I see it. You need to get your Greek prefixes. So for one is what? If you have only one, how do you call that? Mono? For two? Mono, di, tri. Okay, so you're all good at this. What else? Six? So you need to know your Greek prefixes, and you need to tell me how many of each you have. So you have the di for dioxide. Now there is one thing, if it is the first element, you do not have to use mono. You can just leave it as carbon. So you don't say monocarbon dioxide, only if it's the first element. If it is the second element, you do have to say the mono. So you say, how do you call this? Carbon monoxide. So you see how everything in the second one always has the I? If it is the first element, somehow just write it there. You do not say the mono. You do not. But if it is the second element, you have to. How would you call this? If you were actually going to call it by these rules, William. It's hard because you look at it and water comes to you, but you gotta have to think about the rules.
Hydroxide.
How many hydrogens?
2.
So how do you call two? Di.
Dihydrogen.
Dihydrogen.
Oxide.
Is this the first or the second carbon? I mean, the second, so you have to use the mono.
Dihydrogen monoxide.
Yeah. So if it's the first one and it's one, you don't have to use it. But if it is the second one and it's one, then you have to. How would you call this?
Dinitrate. Oxide.
So it's easy, right? Let me tell you what happens. What happens here is that I give you something like that, and what do you think people put on the test? The iron trioxide. Why? Because they confuse the covalent with the ionic, and then they don't know what way it's up, and sometimes they put this carbon 1 oxide. No, that's because you are confusing, and you are like, what the heck, this whole thing got just all messed up, I don't know what I'm doing. And guess what? If you have multiple choices, I don't know about these ones because I use ChatGPT to create the homework. So first they gave me something like calcium, and then it had oxygen, and the only good option had calcium, and all the options were potassium, rubidium, and I'm like, okay, this is too basic. So I told ChatGPT, increase the level of difficulty to medium, and then it gave me others, and we have them. So we'll see if they're good. But you should have options that are naming things backwards, right? That is naming something ionic covalent and something covalent ionic. Keep them straight. If you keep them straight, the rules are not that bad. Now, you will forget about aluminum, zinc, and silver. There are exceptions. And what we do is we don't just work worksheets after worksheets after worksheets. I have them. I can give them to you. They come with the answers. You can practice. But what we do is that we keep using it every time we write an equation. Every time we do something, we name everything. Every time we do something from now on, it's going to start using all the stuff we've learned so that it starts building on each other. But I don't spend a day on naming things because then it takes too long. Maybe I need to. If I see people struggling, then I probably go back and do that. But what we do is literally, so I have them, and by the way, you can do that too. If you want to work on something, you tell the ChatGPT, medium level of difficulty, give me the answers, and you can practice on the one thing that you want to have a lot more practice on. This is amazing. I'm loving this thing. Until it makes a mistake, and then I won't love it anymore. But so far, I'm enjoying it. So dinitrogen pentoxide, any questions on how to name ionic or covalent, or what ionic and covalent are, or any of this? Yes. So yeah, that's a very good one. We have, because the exceptions are what get us, right? So we have two ways, two compounds that I want to remember. I want to remember the one where you have the metal coming out from something that the entire universe knows is +1, +2, and +3, right? I want to remember sodium chloride for that. So I know I don't have to write anything. Just the metal, the non-metal, and I, right? The exception is aluminum, zinc, and silver. The whole world knows that they always play with 3, 2, and 1. Because that's just the way it goes. It's nature has it. Every time we do reactions, that's what they do, right? So we said, hey, everybody knows they're always going to be 3, 2, and 1. They're going to follow that same rule. So we will not write the Roman numerals for those. So, yeah, we don't write, maybe that's confusing too. We don't write the Roman numerals for those either. Now, if we have a transition metal, we do write it. And there are a couple that are not what we normally consider transition, but you need to know that they're written for those as well because they're common and it's usually 2 or 4, maybe other, but you have to pay attention to figure out what it is. So the silver, I just write the name of the metal, like in all of the ionic, you write the name of the metal. And the nitrate. Nitrate is a polyatomic ion that behaves just like chlorine or like oxygen. It's like the non-metal ion. It may have a lot of elements in it, but it's a non-metal ion. And the polyatomic ions will be too confusing if we change the name. So they just let it be. So you just write it, it's a nitrate, it's a nitrate. That's the name of the polyatomic ion and you keep it, right? Now, what I want to show you is one thing that you're going to have to start memorizing, and I may need to go ahead and put it in, so let me close this so this thing won't get too big.